This video uses WinAD to design a simple application using an object-oriented approach. We're going to start by opening up our project. And our project consists of three types of documents. We have a dictionary document, we have a sequence document with a bunch of sequence diagrams, and then a class document. And this is where we're going to focus most of our attention on. The class document shows the structure of the object-oriented classes in our application. We see kind of an inverted tree starting with the TObject class, and each class is represented with a named box. So here is the TEventHandler class, and within each box we see the various attributes and operations of that class. These classes are connected with relationship lines. For example, here we see that the TEventHandler class inherits from the TObject class. Here's another type of relationship where the TShape class is aggregated by the TList. So TList contains a list of these TShape classes. The class diagram is constructed by a palette of tools at the left side of the screen. To add a new class to our diagram, we'll just select the tool and click on white space. We're presented with a dialog where we can name that class. Another way of looking at an existing class, we can select the class and click on the Properties button, and then we can bring up the Class Properties dialog for a class that's on our diagram. Within the Class Properties dialog, we see the name that we've assigned to the class, and that becomes an associated dictionary entry in our data dictionary. Along with the main name, there's also a displayed name, which is by default the same as our original name, but in some cases you might want to put a space or whatever in the displayed name, and this is the name that actually shows up on the diagram. We can also draw connections with the connection tool between different objects, and again, when we do that, we'll be presented with a property dialog. Let's just select an existing connection, and again, select the Properties button, and here we see the Connection Properties dialog, where we have the name and we have the associated relationship, which in this case is a generalization relationship, since the TEventHandler is inheriting the TObject. Once we've added our named boxes representing the classes in our system, connected them with relationship lines, we can click on the Merge Object button at the top of the screen, and that will merge all the information from this diagram and automatically create the associated data dictionary entries. After naming the classes in our system, connecting them with relationship lines, and merging those into the dictionary so we have an entry for each individual class, we're going to select each class and define the attributes and operations of that class. We do so by clicking the Details button at the top, and it brings up a dialog showing a list of attributes for our class. Now, we've already added an attribute by simply typing the name of an attribute and clicking the New button, and it adds that attribute name entry into our data dictionary. Likewise, we can do the same thing for each operation. We just type the name of an operation, click New, it adds it to our list, and an associated dictionary entry is added. For each attribute, if we double click, it brings up an Attribute Details dialog, and within this dialog we can define the data types, access information, and other details about that attribute. We can do the same thing for an operation. We can define our data type, argument list, description, and other information about that operation. All this information that we're defining within this class attribute and operations dialog is going into our data dictionary. So for example, here we see for the event handler class, we can go to the associated data dictionary entry for that class. We see it's composed of attributes and operations, and for each attribute there is going to be an associated dictionary entry. Likewise, for each operation there's going to be an associated dictionary entry. The data dictionary is an alphabetized list of entry names. We see, for example, we have red class entries of type class. We have blue attributes of type attribute and green operations of type operation. And the actual color scheme of our entry names is determined by the colors that we've assigned to those entry types. We can also add structure to our data dictionary. If we select tree structure, we see we now have a structure to all the entries associated with a particular class. For example, we can collapse that collection of entries or expand it. The data dictionary becomes a repository of all the information within our design. As we're adding information to our diagram, the associated data dictionary entries are created. As we add details to our attributes and operations, all that information is stored in the associated data dictionary entries. After identifying all the classes in our object-oriented design, the relations between those classes, defining their attributes and operations, and detailed information about those attributes and operations, we could actually use this design to generate the starting point of our code. For example, if we select the T document class and click on the code button, it will generate the structure of the class. Here's our class declaration with our public and attributes and operations. We also have a stub for each individual function that needs to be further implemented for this class. Under the Format menu, we see we can select from a variety of different languages to generate different types of source code. We might also decide that we want to generate in one go the source code of all the class objects on this diagram. And we could do that from the generate code batch command, in which case it'll generate out the source code of all these classes in one go. We can also choose the customize command, which allows the user to customize the details of how that code generation process works for a specific language. To summarize, this video presents a brief introduction to object-oriented design using a class diagram from the UML notation. The class diagram shows the structure of the object classes, the attributes and operations of each class, and detailed information about those attributes and operations. That information can then be used to generate out the initial source code in a variety of programming languages.